Okay, so this will be an extension to our day 2 video. In this video, we're going to talk about two other things, basically working back from solutions to quadratics and also discussing how the roots of quadratics are also the x-intercepts to a quadratic function. Okay, so first, let's talk about forwards and backwards, so to speak, right? So when we solve a quadratic, right, we end up with two solutions, kind of like what we see here. Well, because of that, we can work backwards to see, what was. So let's say number one, these are the solutions to f of x is equal to ax squared plus bx plus c, right? Some function that looks like that in standard form, right? And I shouldn't even say a function, right? We should say it's equal to a quadratic equation. Sorry, it's like 6 in the morning. Quadratic equation in standard form, right? So we just say that it's equal to 0, right? So because of that, if I just start, so here with what we call x1, right? If I just say x equals 1/2. Well, if I just work backwards from here, right, and try to get it back to where it equals 0, so I'm going to multiply both sides by 2, right? That's going to cancel these two. Now I've got 2x equals 1. And you can see what I'm doing here. Okay, I'm trying to get x not by itself again. And then I'm going to subtract 1 from both sides. So 2x minus 1 equals 0. Okay, then I'm going to do likewise, except with this other solution here, right? So I'm going to say x equals negative 2, or if we work it backwards to where it's equal to 0 again, x plus 2 equals 0, right? Because, I would add 2 to both sides. Okay, so those would be my two factors, right? So this and this give me my two factors that would FOIL back into a standard form quadratic, like so. So x plus 2 times 2x minus 1, right? And if I just FOIL this out, I'm going to end up with 2x squared, right? So 2x squared minus x plus 4x, so plus 3x, and then minus 2. Okay, so then that's really all there is to it. Okay, so all I did was take the solutions and work backwards from that. So let's see another example of that just to make sure that we've got this down. So starting here, x equals negative 3, or again, working backwards, I'm going to say x plus 3 equals 0. Right, so that means one of my factors is x plus 3. And now I'm going to use this other one, x equals negative 2/3. Or if I multiply by 3 and then add 2, so 3x plus 2 equals 0. Multiply by 3 to get rid of this, right? So that would be 3x equals negative 2 now, and then add 2, right? And that's how I get to this point. Okay, and then when we FOIL it out, again, we want a standard form quadratic equation, right? So I'm going to FOIL this out, and I'm going to end up with 3x squared, right? Plus 2x plus 9x, so plus 11x plus 6. Ax squared plus bx plus c equals 0. Okay, and one more example just to make sure that we've got it. Okay, so right here, I would just add 8 to both sides, so x plus 8. And then right here, I would subtract 9 from both sides, so x minus 9, right? And I want it in standard form, so I'm going to FOIL it out. X squared minus 9x plus 8x, so minus x, and then minus 72. Okay, so this here would be my final answer. This would be my final answer here. And this, of course, right here would be my final answer here. Okay, now let's talk about roots, right? So every function has two solutions, or every quadratic function rather has two solutions, right? So what that also means is if we find where x is 0, right? So if I've got a parabola, its x-intercepts, right? There's two of them. One happens here, one happens here, right? And that again has to do with the fact that every quadratic has two solutions, right? So that said, we can use factoring to solve for a quadratic function's x-intercepts because x-intercepts happen where y equals 0, or in this case, where f of x equals 0. Okay, so I'm going to follow this little deal right here. So I'm going to factor, right? And of course, when I factor, I'm going to skip some steps here. Okay, so when I factor, I'm going to end up with x minus 2 times 3x plus 5. And I'm setting this equal to 0, right? Because again, y-intercepts happen, right, where y equals 0, or in this case, where f of x equals 0. Okay, so I want to know what values of x make us equal 0. Okay, so obviously, one solution happens at positive 2, right? And the other solution happens at negative 5 over 3. Okay, so what that means is I'm going to have a parabola. So this is the f of x axis. This is the x-axis. I'm going to have a parabola whose y-intercepts happen at x equals 2, right? And at negative 5 over 3. Okay, so negative 5 over 3, that would be 1.67. So negative 1.67, we'll say, if we're going to scale this properly, about right there. Okay, it's about right there. Okay, so, and let me color code here. So I'll say that one goes to that one, and I'll say this one goes to this one. And our parabola, well, that's number 2, what we just took care of, right? Or my bad, that's number 3 that we just took care of. Okay, so what I want to take care of now is number 2, the y-intercept, right? So the y-intercept, well, where does the y-intercept happen? It happens at x equals 0. So if I just plug in a 0 here, so 3 times 0 squared minus 0 minus 10, right? Well, 0 squared is 0. 0 times 3 is 0. 0 minus 0 is 0. And we're left with negative 10 as our y-intercept. So way down here. And that's going to be my y-intercept there, right? And we don't know where the vertex is. We'll learn how to do that later. But if we look at the symmetry of it, right, its line of symmetry is going to be slightly to the right. So we know it's going to be here and look more or less like this. And of course, we can utilize our calculator's Control-T function to see the table for that. Okay, so that does it for this video. So in retrospect, can we use factoring to solve quadratics? Obviously. How can we use factoring to find the roots or x-intercepts of a quadratic function? Well, we just did that here. All you do is literally factor and just see what values of x give you y equals 0. And that tells you where along the x-axis the parabola touches the x-axis. Okay, that does it for this video. Goodbye.